Hello, this is my video for Lab 2 in Physics 2212 by Julian Perez. The purpose of this experiment was to determine the static charge distributed onto a piece of tape. This was done by taking two pieces of tape of equal dimensions, so they had the same width and the same length. Tape A, the first one, was then rubbed onto another piece and then placed on two hanging objects. Same procedure was then done with tape B, the second one, and then brought up to tape A until tape A began to be repelled by tape B. This was noticed as when tape A began to, in a sense, hover above its original hanging position. The distance between the two tapes was then measured. The main physics concepts used were Newton's law of gravitation and Coulomb's law. Newton's law of gravitation was used to determine the downward force that was acting on the tape. Coulomb's law was used to determine the upward force caused by the charged particles on both tapes. When tape A experienced a force of equal magnitude to its gravitational force, it would then cause the hovering that was seen in the experiment. However, up to this point, everything stated was the same process used in Lab 1. What makes Lab 2 different is that instead of treating the charge on tape A and tape B as a point charge, it is treated as a long line of charges. By dividing the tape into these small portions, each little electric field that the portion experiences can be summed up to the tape's net force. The solution to this model can be found using calculus. This can be done by determining the net electric field's value as the size of the tape's portions approach zero. Another way to determine the value of the net electric force on the top tape is through computational methods, which was used in this experiment. The following setup was used for tape A. Then tape B was brought up close to the tape and the distance between the two were measured. The following data were collected. The tape's dimensions, which were found to be 0.0127 meters by 0.14 meters, gave a total of 1.79 times 10 to the negative 3 meters squared. Using these dimensions, the conversion that 1 gram of tape is equal to 1 meter length of the tape was used and found that the tape weighed 1.4 times 10 to the negative 4 kilograms. Finally, the distance between tape A and tape B was found to be 1.9 centimeters or 1.9 times 10 to the negative 2 meters. Using the collected data, the following calculations were made. The gravitational force acting on tape A would be the mass times the gravity, which was equal to 1.4 times 10 to the negative 4 times 9.81, which gave 1.373 times 10 to the negative 3 newtons. Just like in Lab 1, the tape will at first be treated as a point charge. By treating it as a point charge, then the electric force will be equal to the gravitational force in magnitude. Using these calculations, the charge on tape A was found to be 7.422 times 10 to the negative 9 coulombs. Some assumptions made were to ignore the effects of humidity on the tapes. This was done as I live in Florida and there is a lot of humidity both indoors and outside. The next assumption, which will be pointed out its significance in the next slide, is that the long tape was treated as a point charge with all of the charge concentrated at the center of the long tape. Finally, an assumption made was that both tapes had the same amount of charge and that this charge was evenly distributed along the length of the tape. As mentioned before, the tape cannot be treated as a point charge to make accurate results. For this reason, a program was utilized to better calculate the electric force acting on tape A. The following is 3 different iterations of the code, which show the tape being split up into 10, 50, and 500 pieces. As the charge distribution is considered to be more and more evenly spaced out throughout the tape, the magnitude of the electric force differs more and more from the original point, until finally reaching a point where it does not change much. This final value reached was found to be 2.37 times 10 to the negative 4 newtons. The force calculated by the program, which would be if the charge was spread evenly across the tape, was found to be less than the gravitational force calculated. As it is more accurate to describe the charge as evenly spread out throughout the tape instead of concentrated in the center, the second estimate used by the program is more accurate. From these 2 points, it can be concluded that the charge calculated by treating the tape as a point charge is less than the actual charge present on the tape.